Every single day, millions of doctors and nurses rely on this totally invisible, highly sophisticated engine just to deliver life-saving medicines. And honestly, we take this massive global network entirely for granted. That is, until it breaks. So, welcome to this explainer. Today, we're going to uncover how artificial intelligence is basically stepping in to rescue this vital infrastructure. We're talking about transforming it from a really fragile, reactive chain into a super resilient, intelligent ecosystem.
Think about it. How does a life-saving medicine actually reach you exactly when you need it? We've got to start with this question because, look, we aren't talking about consumer electronics today. We're talking about life or death logistics. If you order a smartphone and it's a week late, yeah, it's an inconvenience. But if a chemotherapy infusion or an insulin pen or a critical vaccine is delayed, the consequences are immediate and profound. Every single tablet and vial goes on this extraordinary journey before it ever reaches a patient.
And here's the thing. Medicine supply chains are uniquely unforgiving. Just a single temperature spike in a delivery truck can render a batch of sensitive biologics, like an mRNA vaccine, completely useless. Or worse, imagine a counterfeit batch slipping into the system. That can literally cost lives. Plus, we're dealing with limited substitution. You can't just casually swap out one missing specialty medication for a different one. So things like resilience, transparency, and absolute quality assurance, they aren't just nice-to-haves. They are absolute, non-negotiable design principles when human health is on the line.
To really grasp this, let's look back for a second. In the early 1900s, supply systems were super local and honestly pretty straightforward. Pharmacists were literally compounding raw ingredients right there on site. Now, contrast that with the late 20th century, which brought this explosive rise in global manufacturing. You'd have active ingredients made on one continent, formulated on another, and then packaged somewhere else entirely. And today? Well, today we are deep into the digital transformation era. We are managing unprecedented complexity and generating literally millions of data points every single second.
Which brings us to a really crucial reality. Our hyper-globalized system is under unbelievable pressure, and the stakes of failure are absolute. When this logistics network performs well, patients get their treatments on time and public trust stays strong, but when it fractures, the consequences are immediate. We're talking medicine shortages, interrupted treatments, and completely preventable harm to patients. See, the traditional models that ran this industry for decades were built for stable, predictable demand. And as we all know, our world is definitely no longer stable or predictable.
Today's supply chains are practically fracturing under these massive global burdens. We all saw during COVID-19 how fast border closures caused a massive domino effect. But the crisis is compounding every day. We're facing severe climate-related disruptions right now. Just imagine a single hurricane wiping out a major IV saline manufacturing hub. That cuts off supply to hundreds of hospitals overnight. You add in geopolitical tensions and these incredibly complex global sourcing networks, and it becomes totally clear. Relying on yesterday's data to guess what we'll need tomorrow is just a recipe for disaster.
So what's the antidote here? Artificial intelligence. And no, we aren't talking about shiny sci-fi robots taking over the pharmacy. For pharmaceutical professionals, AI is an urgent, literally life-saving evolution. It takes these absolute mountains of data and does what human brains simply can't do at that scale. It recognizes hidden patterns to answer critical questions before they turn into crises. It figures out which medicines are likely to run out, which cold chain cooling units might fail, and which global suppliers are the highest risk at any given millisecond.
Okay, so how does this actually work in the real world? It basically starts with a fire hose of raw operational data that feeds directly into machine learning models. Those models then churn out predictions. But, and this is a huge but, the AI doesn't fly the plane alone. It supports the decision-making process, sure, but a human expert always reviews and validates it before any operational changes are actually made. And crucially, the system continuously learns from those outcomes. It's constantly refining its own accuracy and just getting smarter over time.
To make this happen, we absolutely have to abandon traditional reactive software. Think of a traditional rule-based system. It is totally blind to context. It just knows, hey, if stock falls below 500 units, place an order. It has zero idea that a massive storm is about to wipe out a shipping route or that a sudden seasonal disease outbreak is driving up demand. Machine learning, on the other hand, it factors in all of those external variables. It looks at epidemiological trends, real-time weather forecasts, supplier delays, you name it, to predict and prevent a shortage before it ever actually occurs.
To make this a bit more concrete, think about where all this data actually lives.
Over the last 20 years, pharmaceutical companies have poured billions of dollars into enterprise resource planning, warehouse management, and transportation systems. So they've been sitting on these massive gold mines of operational data. Now AI is stepping in as the ultimate translator. It takes all that passive historical data and turns it into real, actionable foresight.
These massive enterprise systems like SAP IBP or Oracle Fusion Cloud, they essentially act as the central nervous system for these huge operations. By layering artificial intelligence directly on top of these powerful planning engines, supply chain managers can monitor the entire globe in real time. They can run these rapid, complex what-if simulations, constantly rebalancing global inventory to guarantee that critical, life-saving medicines never, ever run dry.
And you know what's really cool? The technology is becoming incredibly intuitive. Imagine a supply chain manager just typing a plain English question like, "What's the current risk profile for our active ingredient suppliers in areas with extreme weather?" Generative AI tools like ChatGPT and Claude are being integrated to instantly synthesize that exact analysis. It takes impossibly complex data sets and makes them immediately accessible and actionable for the folks actually running the show.
The real beauty of this whole setup is that you don't even need to be a computer scientist to use it. Platforms like Microsoft Power BI and Tableau take billions of complex data points and translate them into super clean, real-time dashboards. They highlight the hidden risks and the immediate opportunities using really clear visual cues. So healthcare executives can make swift, informed decisions without ever having to write a single line of code.
Of course, behind the scenes, heavy-hitting analytics built on programming languages like Python and R are doing all the mathematical heavy lifting. They're constantly crunching everything, from subtle shifts in disease trends to changing global weather forecasts. They run complex statistical models to optimize inventory and route deliveries through the absolute safest channels possible. Essentially, they handle the mind-numbing math so the human experts can focus their energy on what really matters: high-level strategy and patient care. But make absolutely no mistake about this. AI is not here to replace the clinician or the supply manager. Not at all. It is simply an intelligent partner. Pharmacists, regulators, logisticians, they remain the ultimate arbiters of patient care. The AI just clears away the noise. It processes the overwhelming data sets and presents the most logical, mathematically sound options for the human expert to validate and ultimately execute.
Which brings us to the ultimate goal of this massive technological shift: transforming a fragile, reactive supply chain into a resilient, predictive lifeline. Because the pharmaceutical supply chain of the future won't just move medicines around. It will anticipate needs, predict risks, and make intelligent decisions. We're moving toward a reality where the network doesn't just panic and respond to a shortage of life-saving antibiotics. It predicts the spike in demand months in advance and proactively reroutes supplies to the hospitals that will need them most.
So I want to leave you with this final thought. Consider what this actually means for your own family. What happens to your community when our healthcare systems can predict and prevent medicine shortages before they ever even occur? We are standing right at the threshold of a totally new era, an era where every check counts, every patient matters, and artificial intelligence ensures that the medicine you desperately need is always exactly where it's supposed to be, waiting for you. Thanks for joining me for this explainer. Keep asking questions, and we'll catch you next time.